you have a rectangular box and length x, width y, and height z. So you can draw the box first. So we can draw a box here. So maybe I should take out a photograph of just now that one. Okay, something about the, because I think this is very useful. Okay. So next example now, you have a rectangular box. So draw a rectangular box first. The length is x, width is y, the height is z. Okay, so all this information there. Okay, open a top. So the top I know surface, right? Open top now. So this is open top. And volume is 32. Okay, determine the least amount of material required for the construction. This amount of material construction now, basically what they want is actually minimal surface area, right? So what you want is minimal surface area. Okay. Minimal surface area. So let's find surface area now. Surface area at the top is xy. Xy one top, right? Top. Only one surface only. And then these are the side area. X times z, y times z. Two copies of them, so side area here. So this is surface area. So area depend on three variables, x, y, and z. Very troublesome, three variables, right? We want to reduce it. Okay. Fortunately, we know the volume is 32. Volume above 32 means what? This is x, y, z, right? So x, y, z is 32 now. That means I can get rid of z now. So z is 32 over xy. Okay, that is 32 over xy here. So now I put the z back into the expression. I put it back now. So s surface area now is equal to xy. Put them 2x z 32 over xy and 2y z is 32 over xy. Solution. So this y cancel. Okay, y cancel, and then this the x cancel here. So I'll give you xy plus 64 over y plus 64 over x. Okay. So now, how do you find the minimal surface area? Okay, how do you find? So you must set surface area differentiate by x plus 0 first. So you'll solve this critical point. I say differentiate by x equals 0, you get y. Okay. Term is 0 because there is no x here. Term get minus 64 over x squared. Okay. Y with respect to x, you get y. And then differentiate 64 over y with respect to x, you get 0. And differentiate 64 over x, you get minus 64 over x squared. So this will give you equation now, y equal to 64 over x squared. How about the first equation? Respect to y equal to 0. So you should get x here. Okay, x here. Then minus 64 over y square equal to, then differentiate as with y, you get 0 again. 0. That means that x equal to 64 over y squared. Okay, simultaneous equation. Okay, very often to find critical point, you have to solve simultaneous equation. Okay, find a simultaneous equation, solve it. So this is the first page here. Simultaneous equation. So you can put the, up to you lah, you can put the y 1 and 2 lah. Let's say 1 and 2 now. Then you get what now? X equal to 64 over y squared. Y is 64 over x squared. So end up there. Okay, pen battery corner. Okay, so 1 over 64 now. Means that you're going to solve this equation. 64 x over x power 4. So what is x now? So that means that x equal to 0 or x equal to 4, right? 4 basically actually x here x 64, right? Minus x4. Basically take out of x here, 64 minus x cubed. You get x equal to 0 or x equal to 0 or 3. Okay. Right? Okay. So I find this already. Then you differentiate s another time. So what is s another time? The differentiate just now, right? And you make use of this different x x another time. So you get minus 64 over x squared. So basically you have minus 64. Okay, differentiate minus 64 over x squared, right? So this is actually differentiating 1 over x minus 2 now. So you get minus 64 times minus 2 x power minus 3. So 128 over x3. Okay, so it's 128 over x3. And your x equal to 4, right? X equal to 4, y equal to 4. How do you know x equal to 4, y equal to 4? Because you calculate just now. You calculate, yeah? X is equal to 4, right? You calculate x equal to 4. So y, same thing, equal to 4. Then z equal to 2. Because using the formula, same as x, y, z, okay? You put in the formula for y, okay? You know, x after you find out x equal 4 then you go y equal 4, then eventually z equal 4. So how about this one? It's the same thing here. So this differentiate with respect to y minus 64 over y square. And you find that it's equal 128 also y cubed. So where x equal to 4 now, so you press the calculator. So 128 over 128 over 4 cubed. Okay, divide by 4 cube here. You get 2. And how about differentiate x and y first? So you differentiate y first and x will get 0, right? Because if you differentiate y first with 64 plus 64 over y squared, and then differentiate with respect to x again, there's no more, right? So check again. Just want to double check, okay? Differentiate with respect to x first, then you differentiate with respect to y. Okay, got something there. Differentiate with respect to y, get 1. Okay, sorry. Okay, 1. Okay. Y first and x get 1. Okay, so this is 1 here. So d is what? D is actually, your d, this one is partial differentiation with respect to x, partial differentiation with y, then partial differentiation with respect to xy, and square, right? Is d, huh? So this is actually 2 times 2 minus 1 squared, which is 3 greater than 0. Okay, this is equal to 3, and partial differentiation with respect to x is 2, again greater than 0. So confirm, this is the minimal surface. Okay, so this is minimal because this is actually minimal now, actually positive and minimal. Height is 4, the width is 4, the height is 2. So this is last example.